Hi, I'm Tommy.
Hi, I'm Nemanja. Welcome to Cloud Couch.
It's where we discuss cloud topics from a couch perspective.
Not so comfortable couch.
Welcome back to a new episode of Cloud Couch. So we're continuing the series of Cloud Journey, and we're now going to look at operations, the last part. So very important part, and as we remember what we've done so far, we have kind of put the foundation for our cloud journey, and we have also now migrated all kinds of applications from on-prem into the cloud, and also put up the wiring for development and everything, to continue in the cloud. And now we also need to start looking at how are the applications doing in our systems in the cloud, and that's really what this episode is going to be about.
Yes.
So why don't we start with clarifying what is this operation all about?
Why do we need it?
Why do we need it, and what is it? What's in the bag of operations?
Yeah, I would say quite often operations are in the same bag like testing. Like nobody wants to do it. So testing up front, developers would like to put it aside and focus on the tasks they get from Jira and needs to be done as soon as possible. Operations is also something that is left at the end, and also nobody wants to touch it. Business doesn't want to pay for it. They don't see the value of it. So it's a usual story. I think everybody who has ever been in development or in IT has this impression. However, as long as the applications are running fine, that is the story that holds the water, and nobody needs to take care about the operations. But in those moments when something is not running well, then you wish you had your operations runbook prepared and ready to act in this kind of situation. So I know cases that, for example, if I look at one customer that had an issue with cost, so the application was running in production, and due to some developer error that in the middle of the month came up, the cost went from something that is very, very small, like a few $100s a month, to many thousands of dollars a month. It is the operational issue that should have been spotted at that moment, and if you had tools to collect the data and make alarms or report on those data, the ops team would have noticed that and would stop the bill from progressing through the roof.
Mm-hmm. Yeah, I mean it's one of the many reasons why you should be concerned about operations.
Yes.
Obviously, cost again itself a large topic and important topic, but of course there are so many other things, like just knowing that kind of the way we define it really is about. It's a business thing, because you're running an application because you want to do business. That's part of your business. So it's really about understanding that your business runs and that your applications work the way you expect, that serve your business. Mm. And then whatever's part of your application, software and hardware, works as expected. And then everything goes in there. Are the costs where you think they should be?
Yeah.
Is the performance where you think it needs to be? Are there errors?
KPIs, yes.
All these kind of, let's say, it's not the technical aspect only. It's really like an entire business comes together. Everybody who cares about the business, basically all the different departments and people, should be knowing, are our users happy? Is the application behaving how we think it should be behaving? Do we need to, do something about it? Did the changes that we made recently, do they work as expected? Is it used the way we think it should be expected?
And it's not easy.
Yeah.
It's not easy to do, and that's why people usually leave it out.
Yes.
Putting the application in the cloud, it's very easy. Mm-hmm. You can assemble any kind of application and just put it there. But having it production ready. And with scalable and with all the characteristics that one application in the cloud should have, that is very difficult.
Yeah.
So if we talk about why do we need monitoring of our systems in production, that is as you mentioned, to get this kind of awareness of the situation, where my application is running and how it is running. And then also to provide a timely and effective response to certain events. For that, there should be prepared playbooks for different kind of scenarios, how to do that. And I would say lots of applications that are running in production need to follow some kind of operational principles, let's say, and one of them would be that failure is a normal thing. It happens. So we should accept failure as normal, and it's definitely going to happen. Like no matter how smart engineers are and developers, there are just some things that are out of our control, out of our hands.
Absolutely. I mean, this is so fundamental, and I mean, it comes from even the best of the best in any engineering field. They know that it is just a numbers game, and it became self-evident when cloud became a reality, or even before that, when we got these big IT companies like Google and also Amazon. They had so many hard drives in their data centers that even if the hard drives had such a, let's say, high reliability, with a lot of disks, you had daily disks failing.
Yes.
And the same thing is, with anything, because nothing is 100% secure or working, or it's not perfect stuff. It's very high quality stuff, and it's the best we can do, and it's extremely reliable. But when you scale it out to the scales we're talking cloud and big systems, complex systems, these problems or these probabilities, risks, they compound, and they always will happen. So it is to embrace failure and design for failure and have a plan, and that's kind of what it's all about.
Exactly. So accepting failure as a normal would be major operational principle. Then I would say any kind of change you do in production, that it's a gradual change. So it's not a big bang change, but step by step increments. And for that, you need to have tooling in place. So the automation needs to be well done, so that the changes can be rolled out and rolled back if needed,
yes,
in a gradual step manner.
Yeah, I mean, yes, this is such an important point, and also we have to also remember that especially a lot of enterprise and, let's say, all software engineering, already like 10 years back or 15 years back, they were doing a lot of them waterfall development and long cycles and big bang deployments and all that. But now we know this is not how to do it. You can minimize the risks by doing this continuous integration, continuous deployment and delivery, things like this. And this is exactly what you're saying, which means you have a system that is going to fail. It's running right now. You know how you think it should be running, not just from a technical point of view, but from your business point of view. But you also know you're continuously changing it, and you need to monitor that it's staying within the expected behavior on all the different levels of your organization. And this is exactly that you were saying, and that's such an important realization.
And when I look back in the time of when I was working for large companies like 10 years ago, release cycles back then were like 2 times per year. Yeah. So you had like a release window 2 times per year, and I think back then it was better than today, right? Because then after the successful release, you would throw a party. Everybody would celebrate. Everybody would get drunk, and it would be great. Now, if you have 500 releases per day automated,
you would be drunk every day.
Yes, you don't have time to party. So yeah. It's not all great within new wave, but that's fine. Yeah,
I remember the same thing. I mean, I started out my career back home in Finland at Nokia, and it was the same thing when I joined 2004-05. I remember still they were working on a new version of one of the base station components, actually on the messaging side, and I think that was like a release cycle of more than a year. And of course you can argue, but that's the only way to do it. Of course it's not true, but that was just the way how how they
sure,
were
done.
releasing stuff, because everything needs to be also compatible across vendors and so on. But it's really a high risk thing, and it was always looking good in the beginning of the project, and everybody had good bonuses, and everybody was, all the performance indicators all good, and then at the end there was always a squeeze, because you don't have the necessary feedback early on to also do corrections and know that you're actually late, because it's all quite artificial how you're setting it up. But yeah, in that case, it was also, you were most of the time taking into use completely new hardware, software components, not, let's say, updating an existing
It was complete
hardware
big
with
bang
some
replace.
software. But it was like, really, plugging in new things. But, obviously you can do things much different today. And I think the leader you would be looking at today would be Tesla. Tesla is doing over-the-air updates for the cars.
Yeah, exactly. Was there a party in Nokia after that?
Yeah, I mean, we had good
Okay,
parties
that's
back then.
Okay, that's good.
That was not a problem.
Okay, and yeah, I would say to continue with like principles of operations would be, of course, to measure everything. Now, when we talk about measuring things, we need to, I would say, make a distinction about different levels of measuring. So, telemetry, let's say. So, what are those telemetric data that we need to collect for the to have insight into how our application is running in production? So, I think I would start with system level metrics. So that would be like how the infrastructure is behaving. Everything from the CPU usage, percentage of memory usage, network disks, and like all of these sort of like infrastructural level metrics that needs to be collected to understand the overall functioning of the application.
Yeah, and of course there you have both like hard, let's say, errors or outages and problems, but you also have more performance related, that it's not enough, for you have increase or delays and other things.
Exactly. I mean, when we talk about what needs to be measured or what metrics in the operational world, there is usually this, as it's called, like a 4 golden signals, right? And so those 4 golden signals, they're not all on this sort of system level, but they're on other levels as well. But those would be like latency. So how much, let's say, how much time it takes for your service to respond. Then it would be like traffic. So how many users are reaching your system. Then errors. Any kind of errors that can be on a system level errors or application level errors, and also saturation. So saturation will be how full your service is and how much longer it can run until it reaches the limits. It can be like a database, if you think about it. The saturation, like the disk space is running out, and you need to do something in order to continue scaling your database.
Yeah.
So those would be like a system level metrics, but then on the next level will be the application metrics, which is probably something that is more relevant to application developers, business stakeholders as well.
I would think it's where kind of everything comes together, because it's running on top of the first you said. It's like the system, the cloud, we can say all the infrastructure, hardware, but also maybe managed services that you said a bit. And then it comes to your business. What is it that you have? It's your service, your products, your systems, and how they are interconnected. So you are more looking at, I mean, of course you are also there looking at the same things, like errors and these kind of binary things, but you're also looking at the expected dynamics and behavior, maybe usage,
response time of a web page,
of course,
network round trips of a mobile app, how many calls it, if you're using some kind of queuing system, how much the queue is filled, and how fast it gets emptied, and so these are the application level metrics.
Yeah.
They're not necessarily interesting, let's say, for the business end users. For that, I would say there is this like a third level of monitoring that is these business insights. Also something that is interesting for the end users, and that's different SLAs, customer sentiment, for example, when in the if a customer visits your web page, when do they drop off, for example? What's the drop off rate? How much time they spend on the application? I remember also when I was working on one application, it was very interesting that we have seen that it was for insurance business. We were seeing that users were dropping off before making clicking a button that they want to like make a policy. And the only reason was that this button was lower down in the so if you look at the web page and it's like a visual like that, you don't see it. You have to scroll down to see the button. So they wanted to make policy, but many of them dropped off after looking at okay, good, but I don't know where I need to click. It wasn't so intuitive that you have to scroll down. And so these are the business insights that are very important to at the end of the day, they don't care if your application is super fast and works without errors if they don't close the policy.
They never use it. I mean, for sure. I mean, this is really the tapping into analytics and all the UX and really the product and really what the business is about, and definitely like the you could even argue the most important, because you're building on these foundational layers, the hardware, understanding that the hardware and the systems, the low level are working. Then you have your architecture of your solution, your product, your system, and that works how you expect it. And then you can start testing now. Can we get customers, our users, to do what we think they should be doing? And do we make money? Do they use the new products, features that we were deploying? And all these product-related, UX-related, user-related, and business-related KPIs and funnels, of course, that you mentioned. So all very important things. And of course, in the end, it's also highly interconnected, depending on what exactly your business is doing and how large it is. But in general, it's all interconnected because they all need to work. And they all have...
Not just one layer, all layers need
to work and
within the boundaries in order for the end customer to get the value out of the system.
And I just want to, one last thing, mention, because what's really interesting is that we have this interdependency. Like if you think about it and zoom out and think from the business perspective, which it's all about in the end. It's not about that the hardware runs great, but you do no business. That doesn't make sense. So in the end, it when you have established the whole stack, in the end, it's driven by, are you making business? Is your business running well? And if you have a fully integrated kind of team or effort that understands the different layers, you can start talking about trade-offs in order to achieve what the business needs to do. Maybe you shouldn't, tune it the way that you see if you just look at the lowest layer. Maybe you need to do something completely different. Maybe you need to rethink something in order to achieve what you want to do on the user level.
Yes.
And this is so important that you kind of touch all of them, like coming back to where we started. Yes, you need to do it. You need to think about operations. You need to think about these metrics and all this. But you also need to think about it together in an integrated manner.
Full end-to-end. And what it takes to build such a monitoring system, it always starts with collecting data. So collecting data on all of these levels, and
prioritizing that.
Prioritizing, yes. And also, after that, what do? You respond to this data, or you visualize, let's say, data. I mean, I think visualization is always important, to have like a dashboard where you're observing that everything is running normally, that there are no anomalies or glitches. But in case something like that happens, the dashboard itself is, if you see it, it might be too late for it. Maybe you're not in front of your dashboard, but some kind of automatic response needs to be in place. For the things that are possible to create in a, what we like to say, like in a self-healing manner, right? Not everything can be done in a self-healing, but if your underlying, let's say if you're in the cloud and your underlying host dies, your virtual machine can be recovered, can go into self-healing mode and be run on a different host.
Or a failover or whatever.
Failover, there are lots
even on region level.
Yes, there are a lot of different ways how to design the systems for automatic failover. But important is to collect the data and then visualize or respond to that.
Yeah, just maybe before you continue, I just want to add that respond, you already said it a bit. And I would think just to kind of also see how to evolve it, because it's like everything else. You can't think it's a binary thing. You need to have everything in place before it works. Well, in the beginning, if you start on a new product, and especially that's what I know very well, you start from the beginning, well, you shouldn't like discard operations and monitoring and collecting data simply because you don't have the capacity. You need to start somewhere.
Yes.
So what's the most important, response, or the most critical system, or the most valuable system? Well, start here. Start collecting the data for this. Start putting in place a visualization for sure, because initially you need to maybe also learn a bit yourself in terms of your system and usually the dynamics and how it behaves. But then quickly you should start to get into these things like automation, because that's cheaper, scalable, and so on. So you can see, okay, if these things happen, let's say it's a capacity related thing, well, let's spin up more resources, or let's do this, or let's do that. So you get into this automation responses, and then you get into this self-healing, and I think, or self, you have a resilient system that can, take care of certain problems. And the way I usually think about it is that that's the perfect thing that you want to have as the guiding star, where you're thinking you want to bring everything to that level. And then it's just a matter of prioritizing what you're doing and looking at how you can do that.
It's a step-by-step work. And if let's maybe talk a bit more concrete about the services that you actually can use. In this case, let's say if you're running on AWS cloud, and AWS, in our case, we're going to use it because we know it the best. So if we talk about collection of data, what are the services that we usually can use, right? So I would always start with the CloudWatch, which is the main infrastructure monitoring service that collects different metrics from different services that are used in your application. Logs are being shipped to CloudWatch. This is where you can detect certain anomalies and get lots of insights into how your environment is working. That would be one way to collect the data. There is also, I would say, if you look at the networking level, there are lots of services that can provide you networking insights, like VPC flow logs, so where the packets are flowing inside your VPC from one instance to another. There is like traffic mirroring that you can use to further inspect what kind of packets are coming into your instances. Also, the different DNS and gateways can provide, load balancers can provide these kind of logs. All of that you should ingest and then do something with it, right? Either create some automatic response or visualize the data. If we talk about security, let's say the data that we can collect as a security logs, they're also coming from lots of different places, like CloudTrail, collecting all the API calls in AWS, config, so changes in your environment. Then if we look at Amazon Inspector, Detective, Macy, so all of them are shipping some kind of logs. And as you said, it's difficult to get all of that at once and do something meaningful with it, but it's a step-by-step process. Start with CloudWatch logs and build from there onwards.
Yeah, this is exactly the thing, and maybe to add a few points to all that. So, of course, it's also, I mean, on depending on scale, and of course it depends on what system, what exactly are you doing, but so there might be some certain trade-offs or certain things you don't do or you would do because there's a lot of data that it generates. But in general, let's say, you want to start collecting data, and what, like we talked about in the foundation episode, we have a logging account where all the logs go. So a best practice would be, let's start from day one. Let's collect these foundational logs and data just from day one. So even if we're not using it from day one, we're just collecting it, because why is that important? Well, we have it, it's not costing that much, it's very easy to do, and it's foundational for anything that you want to do in the future, all the way from using built-in already available things, say on AWS, but also all the way up to custom yourself analyzing and inspecting maybe dynamics, behavior of your systems and security, topics, everything.
You have a history of your system that even if you introduce tools later on, you can run it against the historical data and get certain insights.
Yes. Yeah, absolutely. And the last thing I just want to mention, just so it's clear to the listeners, obviously we have, like, if you think about on a very crude high-level view, we have like our AWS inside the box, where we have even different, well, we can even say we have could have different regions, but we definitely have different accounts. We have different VPCs, and these are different containers. So you have like a big container, like our whole AWS footprint, then we have the regions, then we have accounts, then we have VPCs, and these are just drilling now down into different points. And then we have whatever is on the outside that interacts with this, AWS. What goes in, what goes out, what happens inside, and all these, and what happens between these boxes.
Yes.
And these are all the things that you need to think about, because you can monitor everything. You can collect all the data from all these different points. It accumulates data. So if you ignore cost and space, you can enable everything also for later, so that you can come back and look at it. But otherwise it would be a priority order where you're just looking at, depending on what you're building, you will just enable and start logging the data that fits best for your purpose.
And that is about collecting the data, and as you said, the prioritization is very important. Then what do we do with this data? So we can visualize them, and there are lots of tools to do. Some are also some services in AWS come with their own dashboards that you can use. So CloudWatch, for example, has a dashboard. And if you use X-Ray service for microservices for request tracing and looking at different bottlenecks, for example, it's a nice service that shows you the map of all the microservices, how they interact. Services like Security Hub, GuardDuty, they also have some kind of dashboards. But what I've seen customers doing a lot is using third-party services that are more, I would say, specialized in the area of operations and dashboarding, visualization activities. So it would be like things like Grafana, Prometheus, Datadog, Kibana, Splunk. All of these tools can be used to visualize data and give you some kind of insight into how your applications are operating in production. But we also need to respond to those data if there are certain actions. It's nice when everything is running fine and we see that in a dashboard, but if something is not running well, then we should automate what can be automated. In AWS case, for example, there is something called CloudWatch alarms that can be triggered on a certain actions. So if something, it can be, let's say, if it detects error in the log, CloudWatch can trigger alarm, and then you can do something with it. You can very easily notify admin team through email or integration with the Slack, for example. And they can do something about it. Usually companies have like a playbooks, and for the different incidents, what are the steps that need to be done in order to mitigate this situation. But there are also some automated actions that can be performed by the system itself. So some self-healing actions. Let's say if you integrate CloudWatch with Lambda, and Lambda can trigger certain actions to modify, let's say, security groups, a web application firewall, whatever needs to be done in response to event. Right.
Yeah. And I just want to add there a little bit. So, like we said before, like we're collecting data, and then I just want to make clear again how you can think about it, not in a binary way that you just conclude you don't have budget or time or anything to do anything. So collecting the data is very easy, as we said. In many cases you can do it, and it's just there. And then even if you don't have time to automate it, or you think that's too much or whatever, but think about how you can use, first of all, it's data. Then it's about prioritizing what you care about. So things that can go wrong, or systems, again, depends on what you're building. And let's say, well, it's too much time to make the playbook. Well, okay, let's make it blank page now, but it's here, and you can start writing on it whenever you have time, or as you're evolving things. And then you can say, it's too much time to automate, but, well, you could, just make some notes, what you would like it to happen if you would have time.
Yes.
But first of all, at least if something breaks, what would you like to do? No matter time, if it's in the middle of the night or something, let's say you want to, send an SMS to Nemanja and say, hey, now you need to, jump to the computer and take a look. Well, then you would do that. So you would send an SMS, and that's rather easy, and then it's up to you to do whatever random you do. And then the next evolution would be, okay, Nemanja realizes, okay, I don't want to wake up every night. But it's very easy to fix the problem. So let's look at the automation and write it in the playbook. Or let's write it in the playbook, and then we can say every second night the SMS goes to Tommy.
Yes.
Just to think about how you can evolve it in steps, rather than thinking, no, it's too much playbooks and automation and this. No, it's really the same. It's all on data. What do you care about? What's the cheapest thing you can start with? Well, a person. And and then gradually going towards more of these things you care about and automating more.
Yeah, I heard a great discussion. It was on Twitter some time ago, how the operation can be randomized in companies, and somebody suggested really cool thing. I don't know if any company is doing that, but it is to have an internal system to send employees randomly on holidays. For 1 day, 2 days, doesn't matter. You just get an email like, tomorrow you're not in the office for 2 days, let's say 1 day or 2 days. And then see what happens, right? And then if there is an issue with the system, and if that person is on holiday that day, is there a backup? Who gets it? And this is a really good way to minimize the key person dependency and see if your automation and playbooks and knowledge sharing, if everything is in place. So start sending your employees on random holidays. Everything will be much better.
Nobody's gonna have a problem with that, I guess. It's very good.
So I think that concludes the operational discussion. I would mention one interesting service that was just released, reInvent in AWS, and that is called Fault Injection Simulator. It's still in the preview, but it's going to be this year available. And that is like a chaos engineering as a service. So this is a great...
What does that mean?
That's a great service to keep your operations in line, in check. It injects failures in your AWS environment. It could be like a simulation of availability zone is not there, or it can randomly switch off some EC2 instances, or a database can lose the connection, to make sure that you have properly created like a multi-AZ database structure, then it can, if you're running a cluster, Kubernetes or ECS cluster, it can randomly switch off some worker nodes or master nodes and see what happens. Right? So I think this is once you have your operations done properly, let's say, and you think this is good enough, run this service to see if you're really in a place where you should be. I mean, big companies like Netflix and the others, they're doing that, of course, but it's not for everybody. But it's just good to know that there is such service to be used.
Yeah, this is actually really a great thing, and it also allows you to think about where you need to aim to get to, and it's not like perfect or holy grail or some other thing. It's really that's where you need to be, and that's the place where you feel confident to have this automation that does crazy stuff with your system, intentionally trying to fail it, and your system is built in a way where it's resilient and can itself recover. And that's really what you need to aim at and think about from day one, and know that that's where you need to get to. And how do you build incrementally every single day, maybe writing a line in your playbook, maybe, a little bit thinking about how could an automation be, meanwhile you're just spamming SMS, thinking about how you can improve the quality, all these different aspects towards eventually being on a place where you feel system is really resilient, architecture is very flexible, we have a lot of fault-tolerant systems and redundancy, high availability. A lot of things are, and high automation, high quality. Engineers are top class and they love it. And they can even have, in addition to this service, they could have, on Friday they drink beer and then they can use the console with admin access and do stuff.
Yeah, I mean, I would say the ideal situation, it would be that as a CIO, you would go and say, I dare you to use fault injection simulator, and I'm not going to care about the result because I know my system is going to recover well out of it.
Yes.
With that, I would say we closed the operations in the cloud episode, and also I think we wrap up the whole cloud journey series, where the focus was more on now like larger enterprises, but in the following episodes we're gonna go a little bit different track and talk about startups in AWS, how they can startups in the cloud in general, how they can leverage the cloud and why would they do that, what's the benefit and so on.
Yeah, absolutely. It will be a very interesting comparison, and also what we want to do is, of course, revisit and come back to enterprise and talk about startups and enterprise, usually in the same kind of context and discussion, because the reason is that we are moving into a future where they need to converge, because they can't be different, because it's all about, there's a formation of a certain type of tech company and tech organization, and they all need to look the same. So we need to find out, depending on where you come from the startup camp or you start from the enterprise camp, we are all meeting at some point.
And we'll have the same problems, the same issues, and the same operational issues to be solved.
Absolutely.
Cool. So stay tuned and see you in the next episode.
Thank you. See you.
Bye.
So if this is a relevant topic for your business, just contact us so that we can help you.
If you like what we are doing, please subscribe to our channel and like our videos.
And also, you can give us feedback and also suggestions for topics that you would like us to discuss and go into more detail.
In any case, stay tuned and see you soon.